Hello and welcome. I'm Mensa Augustine. In this math video tutorials, we'll be looking at linear homogeneous second order differential equation with constant coefficients. In particular, we'll be looking at homogeneous linear equations with constant coefficients whose characteristic equation or auxiliary equations have complex roots or complex conjugate roots. So let's see how we do this in a very few steps. Remember to like, share, comment, and follow us to board the mathematics community. Now let's take this example. We have to find the general solution and hence the particular solution of y prime prime minus 4y plus 5y equal 0. So let us write the auxiliary or the characteristic equation. This is m squared minus, this is prime, 4m plus 5 equal 0. Now this quadratic equation does not factorize, so we have to use the quadratic formula. So let's take m equal negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So our our b is negative 4, a is positive 1, and c is 5. So we take m equal, b is minus 4, so minus minus will give us positive 4 plus or minus the square root of, if we take negative 4 and square, we get positive 16. Then this one is minus 4 times a is 1 and c is 5. All divided by 2 times a is 1, so 2 times 1 is 2. That's good. Now we have m equal 4 plus or minus the square root of, if we multiply 4 by 5, we get 20, and subtract from 16, we get negative 4. All divided by 2. So we get m equal 4 plus or minus 2i, all divided by 2. Now you have to remember that square root of negative 4 in the complex word is 2i, which gives m to be equal to 2 plus or minus I. Because if you divide 4 by 2, you get 2. If you divide 2 by 2, you get 1, in a very simple way. So you see that the roots that we have here are complex, are conjugates. So we take our general solution as y equals, this is what we're going to have the cosine and the sine. So we have e power ax, that's it, into a1 cosine of x, cosine of bx, right, cosine of bx plus a2 sine of bx. So this is the general solution for homogeneous second order ODE with constant coefficient whose auxiliary equation or characteristic equation have complex roots. So what is A? A is what we have here, and B is the coefficient of this I. So we take y equals e to the power 2x into a1. A1 and a2 are constants. Cosine of b is the coefficient that we have here, that is 1. So 1 times x is x plus a2 sine 1 times x is x. Wow. So this is the general solution. Now let us impose this initial condition on this equation. If we have y naught to be equal to 1. Wow. And y prime of 0 equal 5. Then we have to find the particular solution. So if we impose y of 0 equal 1, then we have 1 to be equal to, if we put 0 for x, e power 0 is 1. So this will go. We're going to have a1 cosine of 0, because 0 times b will be 0, plus a2 sine 0, because 0 times b is 0. Now we have 1 equals a1, because cosine of 0 is 1. 1 times a1 is a1. Sine of 0 is 0. 0 times a2 will be 0. So we have a1 to be equal to 1. Now, to impose y prime of 0 equal 5, you need to find the first derivative of the general solution in a very simple way. So now let's do that. We have the product, that is e power 2x multiplying whatever is inside here. So we take y prime of x to be, we differentiate e power 2x, so just take 2x and differentiate with respect to x. That will give you 2. Then multiply it by the general equation e power 2x times whatever we have here, a1 cosine of x plus a2 sine of x, plus, then we differentiate what is here and multiply it by e power 2x. So let me bring e power 2x first, so plus e power 2x times, if we differentiate cosine, you get negative sign, so you have minus a1 sine of x plus a2, if we differentiate sine, you get cosine of x in a very simple way. So we can now impose the condition y prime of 0 is 5. So we get 5 equals, if I put 0 here, 2 times 0 is 0, e power 0 will be 1 times 2 is 2, into cosine of 0 is 1, so I'll get a1. Sine of 0 is 0, so a2 will go, plus here e power 0 will be 0, and then sine of 0 will be 0, so this one also go, and cosine of 0 is 1, so plus a2. So I have 5 equals a1 is 1, so we have 2 times 1 plus a2 in a very simple way. Now this is gonna give me what I have here as 5 minus 2 equals a2. So a2 is gonna be 3 equals a2 in a very simple way. I hope you've seen that. So we have a2 to be 3, and then we have our a1 to be 1. So we can write the particular solution. So let's find some place here and write the particular solution with this, right? So we're gonna have y equals, with this one, e power 2x into a1 is 1, so 1 times cosine of x will give us cosine of x, plus a2 is 3, so we have 3 times sine of x as the particular solution. Now try this one, y prime prime minus 6y plus 25y, this is prime, equal 0. We have to find the general solution and hence the particular solution if we have this initial value problem, y naught equals 3 and y prime of 0 equal 1 in a very simple way. Thank you for watching. Bye bye.